Hi everyone, I'm Brent Shively, Product and Application Trainer with Festool USA. So in the last build series, I built a mudroom cabinet in my personal shop. I had a lot of questions on how I laid out my shop, some of the other projects that were in there, and the MFT Work Center. This series, we're going to focus on that, building that MFT Work Center, which is going to be the important first step for outfitting the rest of the shop. Over my 30 years as a carpenter, I've worked in a lot of different areas. Remodels, new home construction, even my own shop. One thing that's remained the same is I've always liked to have a centralized location to store my tools, to complete my work. And that's why I've come up with the design of this rolling cart to help maximize the small space that we have here. What are you using on the job site or in your workshop as a work center? Let me know in the comments. So in my design for this rolling MFT cart, I really focused on the things that I utilize the most. The top is going to be an MFT for the work area. And then right next to it, I'm going to have a spot for the VAXIS. So when that VAXIS sits on there, it's the same height as my MFT. Then underneath, I've tried to design it for the main tools that I'm going to be utilizing. We've got a spot for the SysGen 3 rails as well as our SysAZ drawers. Spot to hold the vacuum pump for the VAXIS, as well as the parallel guides and just some general storage areas. And this can be completely customizable to fit your needs. I've also put casters on the bottom of this, so if I need to move it around my shop, if I need to assemble a larger project, I can do so. I can also, if I need to take it to a job site, roll it right on the back of a trailer, transport to the job site. All right, to build out that rolling MFT cart, we're going to be using several different tools. First one to break down the material is the TSC 55K, and then we'll use the 1010 router to plunge the LR32 holes. Then we'll pick up the DOMINO 500 to do the connecting of the panels with the DOMINO connectors. We'll also, in between there, we'll be using the T18 and the TID 18. And then we'll finish everything off with a little bit of sanding with the DTS 400C and the ETS 125C with the edge sanding attachment. And at the heart of the system, I'll be using the CT48AC for the dust extractor with the work center on top that'll hold clamps, my parallel guides, any other accessories that I may need. As far as the material for the project goes, you can get as fancy as you want. I didn't go too crazy. I'm going to be using 3/4 inch maple plywood, good on one side. And then for the banding, I'll be using solid maple. The reason I'm using maple for the banding is I want something hard and durable to protect those edges in the workshop scenario. So with the tools all ready, I've got the material ready. The next step in the process is to work off this cut list to break down the sheet goods for the carcass of the MFT3 cart. If you want to follow along during the build of the MFT3 cart, or if you just want to build your own version of the MFT3 cart, you can get a full set of plans and a cut list at festoolusa.com. For breaking down these sheet goods, I decided to use the STM 1800 to lay all my sheet goods on. You could use an MFT. You could also use sawhorses if that's all you've got until you get your MFT cart built. For every project that I build, I always have a cut list of some sort. It could be on my tablet, it could be on a chunk of wood, but that helps me to keep the waste down. With this project, however, there were specific sizes that I wanted to build this at, so I will have some extra waste, but we all know there's truly no waste when it comes to a wood shop. I'll use these someplace. On the TSC 55K, I'll be using the 42 tooth fine blade with the 1.8 millimeter kerf. The first step in breaking down sheet goods is always creating a good clean edge to reference all your cuts off of. So that's what we'll do now. So the first cut is going to be the 734 millimeter rip, and then I'll come back and do all my cross cuts for these pieces, and then I'll jump on to the next piece of plywood. So all the measurements that I'm going to be using are metric, not imperial. A couple reasons for that. That's what I'm used to. Also, when I begin to drill the shelf pin holes with the LR32 system, I want this cabinet, the dimensions, to be divisible by 32 millimeters. You can switch it over to imperial, you just have to do that math. So the width of this first rip is going to be 734 millimeters. So I'll mark that on both ends. So I'm going to go ahead and spin this around to make the cut. Always be aware of your surroundings when you're flipping a guide rail around, especially if you have sprinklers in your shop. So I'll go ahead and line up my splinter guard, which is this clear plastic piece, because wherever I line that up is exactly where my saw is going to cut. We'll be cutting a small piece out of this later, but for now I'm just going to set it on the ground. You may have noticed that I've got the good side of the plywood facing up when I make that cut. Typically with a circular saw or even a table saw, you'll have that good side down to reduce chip out. With the guide rail and the splinter guard on the guide rail, as well as the tooth design of the saw, I don't have to worry about that. I can cut with the good or the bad side up and I will have zero tear out. So now I've got two parallel edges on my piece of plywood. I need to create a cross cut that's perfectly square to those edges. What I'm going to use is just a good quality square. Line it up with the edge. Line my guide rail up against there. Make my cut and I know it's perfectly square. So now with a perfectly square edge to my two parallel rips, I can begin cutting my other pieces. The first three are going to be all 544 millimeters. I could sit here and measure each one, but instead I'm going to go ahead and use my parallel guides so I know that each and every one of them is going to be exactly the same. With the parallel guide set up, before I make any more cross cuts, I want to switch out the clear plastic viewing window with the green splinter guard. With that on there, that's going to give me a completely splinter-free cut on both sides of the blade. Now I'm going to go ahead and cut three of these at 544 millimeter. So I brought up that scrap piece that I had earlier because there was one more piece I had to cut out of that, and it's exactly 544 millimeters, just like the ones I was cutting before. I'll just go ahead and cut that to the proper length, and then I'll be done with that length for the parallel guides. So now I'm going to go back to that first piece I was cutting all those cross cuts off of, and I need one more at 155 millimeters. This time I'm going to be using the narrow side of the parallel guides. Because I already know this piece is square, if I set these both at 155 millimeters, I know it'll be square and parallel. So now I've got the parallel guide set to 498 millimeters to do the final cut of that first piece of plywood we broke down. So with that first sheet of plywood broken down, I was able to utilize the parallel guides for the repeatable cuts. This second sheet, most of them are going to be one-off cuts. So it's just a matter of measuring, marking, lining up the splinter guard, and making our cuts. So if you notice that dust coming out, it's time to change this bag out or empty the bag. Figured it up, I've done around 35 feet of ripping on this 3/4 inch plywood with just this single bag. No camera tricks. I'll show you what we've got in here. So that's just with this bag, no dust extraction. So I'll start breaking this sheet down just like I did the other one. Now that I've got a nice straight edge to reference off of, take a good quality square, put that up here, line my guide rail with it. Now I can make that cut knowing that this edge is perfectly square with this edge. So later on in the project, I'll talk more about layout. For right now, I know that this is the first rip I did, this is the first cross cut I did, and that they're perfectly square. So I'm just gonna put a square there because I haven't cut anything on that edge over there yet, but I know this is the edge that I want to reference off of. So with that cut done, I know my width is 734 millimeters. So I'm going to go ahead and mark that on there. But I haven't cut it to width yet. I know off the top of my head that that is 1175. So I'm going to put that on there, but I'll come and cross cut it at a later date. So this will be the final cut of the base of the rolling MFT cart. With some of these narrow pieces, once I get my length marked down, I'll just run my square up against there, run that across, then I can just line my guide rail up with my pencil line and make my cut. This will be the last piece of plywood we have to break down. So now that I've broken down all the sheet goods, I've got everything cut to size, the next step is going to be to break down the hardwoods for the face frame material that I'm creating. I'm going to just put a scrap piece of plywood on top of the STM for a work surface. So for ripping down the hardwood, I'm going to switch over to the 3000 rail. And because I've calibrated these parallel guides to the saw prior to all this, I can take these parallel guides off the shorter rail, put them on the longer rail, and my accuracy will still be there. So when I rip this hardwood material down for the face frame material, I want to make it just a little bit wider than the actual plywood itself, which is about 18 millimeters. So I'll make this about 20 millimeters, and then I'll come back later with a 1010 router and a flush trim bit to get it nice and flush. So the maple that I'm using is a little bit of a warp to it. It's not really going to matter because I'm going to be ripping it down to narrow pieces, but I still want to use this other piece as a backer for my parallel guide. I can cut one piece, take it out, remove it, and just keep doing that, and I'll always have support for my guide rail. So I just went ahead and switched the blade to a 28 tooth ripping blade. It's going to speed up the cutting process a little bit. So this board has already been surfaced on all four sides, so it's got a nice crisp clean edge that I can reference off of, so I don't need to worry about putting a new edge on it to reference the parallel guides. I went ahead and paired the Bluetooth batteries to my CT48 AC, and I can make the cuts from there. So in total, we should need about 5 of these. I'm going to cut one extra just to be safe. So now that I've got the narrower stock ripped down, I can go ahead and rip down the wider face frame stock for the shelf areas. Those mortises that are cut into the face frame that you're seeing on this diagram, those are for a reason we'll get to later. So with that one cut, we're done with all the ripping of the maple, hardwood, and the plywood itself. For now, we'll reset for working with the LR32 system. One thing I always like to do before I get to assembly and layout is double check all my measurements. I look up the set of plans, make sure everything's what it should be. One thing that has changed is I just received my casters, and they're slightly taller than what I drew my plans up for. What that's going to do is make my rolling MFT cart taller than my MFT. I don't want that. I want them the same height. So what I need to do is cut down all my center panels about 10 millimeters. Luckily with the Festool system, that's going to be a quick and easy process. So I've gone ahead and I've labeled each and every one of my pieces for the cabinet itself. And I've also started to actually mark and lay out each and every piece where it goes. That way again, so when I start putting the domino connectors in, I can see where my domino has to go, where my base plate has to go. Just makes it a lot easier for assembly. You can do it however you want, but I've found the more I mark, the less I mess up. This is also a great time to test fit your pieces, to see if they fit inside the drawings that you've done on top of your project. Sometimes the drawing you do on your 3D software does not line up with what you actually cut. And that could be just a variance in thickness of the piece of plywood. So this is a great time to make any changes that you might need to. As I'm laying stuff out, another thing I like to do is measure as little as possible. Once I have some of my marks on here, the main reference marks, then I'll just take my material, line it up where it goes, and transfer the marks that way. There's a lot less chance for error by doing that than when I measure. So the main reason I've laid everything out up to this point is for the dominoes, obviously, but also for the LR32 system. I need to know where to reference my guide rail and my router so I get my holes in the right position. Another thing you need to take into account is the thickness of that face frame material we're going to be using. Because each time I do the first set of holes for those drawers, I'm referencing off the face of the cabinet, which is going to be the face of my edge banding or my face frame material. I always want to make sure that I account for that so that when I'm done, the drawers themselves are going to be perfectly flush with the front of my face frame. So because I'm using both the SysAZ drawers and the SysGen 3 rails for the sustainers, I like to lay out exactly where my holes are going to go for the LR32 system. That way, I don't get confused when I'm switching back and forth between panels. So I've gone ahead and I've already attached the stops to the bottom of my guide rail. And what those stops do is they align these holes on the panel so each one, the holes are exactly the same. So when I put my drawer in, I'm not getting a drawer that's tipped up and down. In my case, I went ahead and I designed this panel and this whole cart so that this panel is divisible by 32 millimeters. What that does is that when I flip this over, those stops fit snugly right on that panel. So whether I'm coming from this direction drilling my holes or if I'm coming from this direction drilling my holes, all the holes are going to be aligned perfectly. Now, if your panel isn't divisible by 32, that's where marking your top and the bottom of the panel comes into play. What I've done in the past, if I have a panel that's not divisible by 32, I'll just mark one side of my rail as the bottom. And I know each time I drill my holes, I always want that bottom mark on my rail to line up with the bottom mark on my panel. So the next thing I need to do is get my edge guides put on here to line up the holes front to back. And that's just a matter of snapping them on the rail, and then the two pins on the front will drop down, and then I'm set, and I know that I'll be exactly the dimension I need off the front of my cabinet. Once my guide rail is positioned correctly, I want to make sure that I secure the guide rail to the material, but also secure the material to your workstation. Once the guide rail and the material is secure, I can remove the edge guides, and we're ready to punch some holes. So the bit that I have in here is the flat bottom bit. There's two bits that come with the system. The through bit, which will plunge the hole all the way through, or this flat bottom bit. I've gone ahead and set my depth. With everything lined up and clamped, this pin will now line up with these holes in the guide rail, making everything exactly the same distance apart. With those holes done, I can move on to the rest of my panels. Because I've already got my stops set to this dimension for the SysAZ drawers, I'll go ahead and go through all the panels, get those done first. And then I can come back, readjust it to do these, so on and so forth. Just the process that I like to do. If you have questions about the LR32 system, check out the link in the description. So now I've got the holes closest to the edge of the panel done. I need to do the holes in the middle of the panel. Issue is, that doesn't reach to reference off the edge of my panel. So what I've done is lined up my guide rail and my router so that the bit on my router is directly over my line. And I can take one of my edge guides, loosen it up, reference off the back lip, tighten that down, do the same thing with the other one, and then I can run through the rest of my panels. So for these holes, they're going to be 17 millimeters off the face of the plywood, not the edge banding, the plywood. So we have these last two sets of holes, and then we can move on to the next steps. So with all the holes drilled, and I've got my panels laid out where they're gonna fall, next thing I want to do is get down to the details and lay out where each and every mortise goes. I'm not pulling any measurements, they're just reference marks for me. Because I'm going to be flipping back and forth, it gets a little confusing. Again, I'm not drawing any measurements. All the accuracy is going to be from the domino itself. These are just reference marks for me. So with all the holes drawn for the mortises, now I can draw the hole for where this domino connector is going to go. I'm just going to have two in each end of the panel. So I'll put one right here, one right here, there, there. Again, these are just reference marks. They're not exact measurements. The domino will give me the exact measurements. So when I'm putting all these panels together, rather than having 25 clamps in my way, this will work as a clamp holding those pieces together as I get everything glued up. So I've made all the adjustments to the domino with the correct settings. I've got my fence height set to 20 millimeters. That can be left for pretty much the whole project. All my material is about 3/4 of an inch, which is about 18 to 19 millimeters. I've also got the depth set. That's set at 28 millimeters. Now, I'm using an 8x40 tenon. Typically, you want half the tenon in one piece and half the tenon in the other piece. So that'd be 20 millimeters and 20 millimeters. But because I'm using these domino connectors, when I put these in here, I have to plunge at 28 millimeters for this. So that means I'm going to have an offset tenon. You're going to have two settings, 28 millimeters and 15 millimeters through the whole process. Think about when you're plunging in to the end of a panel, I can go as deep as I want. That's your 28 millimeters. But if I'm plunging down into the panel, I don't want to go 28 millimeters because that'll blow through the back of the panel. So that's when you're always set to 15. Remember, I said I'm going to rely on the accuracy of the machine. That's why I added these cross stops, because I can preset the dimensions in between each mortise. Then I'm completely relying on the accuracy of the machine. Now I'm going to have 6 mortises on the bottom of this panel. Only 3 of them are going to be tight. The rest are going to be loose. The first one that's tight is going to be my alignment mortise, which will reference off of one edge of the plywood to keep all my panels aligned. The other 2 are going to be for these domino connectors. Those have to be tight. The rest can be loose to help with the assembly process. So for this first mortise, or my alignment mortise, I'll be using the flaps on the domino, which is exactly 37 millimeters from the flap to the center of the bit. So the second one is still gonna be the tight setting. It's gonna be for one of my domino connectors. And I'm gonna reference this pin off the edge of my plywood. So the next two are going to be in the loose setting. To do that, I have to make sure the domino is running to change this dial. So with 2 mortises to go, the next one is going to be for the connector. So I have to make that a tight mortise, and then the last one will be a loose mortise. So with those holes done, I can flip the panel around and do the mortises on the other side. And this is exactly why I talk so much about labeling everything. Because when you start flipping panels around, you start getting confused. But if you have your marks on here, you know which side you need to reference your machine off of. So this side of the panel will be the same process. I have 2 tight, 2 loose, 1 more tight, and then 1 more loose. But I'll be starting from this side, because if you remember, I flipped my panel around. So with the end panel mortises done, I can work on the bottom panel mortises. So when I do these, I'm gonna be in the vertical position. So I've added the support base for a little more support. One other thing we have to make sure we do is switch over to 15 millimeter plunge depth so I don't plunge all the way through my bottom panel. The mortise width setting will mirror what I've done previously. Also, I haven't pulled out a tape measure yet. I'm still relying only on the measurements of the domino. So with all the mortises complete in that far left panel, the next thing I need to do is put the mortises in the top piece of plywood where the MFT is going to sit. So I've gone ahead and flipped that over, and now I'll follow the same process I've done to this point. So the next step in the process is to drill the hole for this part of the domino connector. To do that, the domino connectors come with a drill guide as well as a drill bit with a collar stop on it, so I can only drill so deep. This drill guide fits right inside my 8 millimeter tenon. Lines everything up, the rest is easy. Same process for the other hole. So with those 2 holes cut, I can flip the panel around and do the last 2 on this panel. So this end panel is completely finished. Now I can start working my way to the other panels from left to right. Gone ahead and I've clamped a board on my center panel right where that center divider goes. So now I can take my domino, reference the back of that right off that board, use my flap on both sides, and I've got one center line drawn to put a mortise right in the center. This board is just for reference purposes only. I'm not actually going to mortise into it. So with this all done, we can start to focus on the mortises on the center divider. Because my end panel is going to be pushing the center panel in 3/4 of an inch, I'm just going to use the side of the domino to reference off the side of this panel. I'm not going to be using any flaps. Because this center panel will be locked into place from the end panels and then the top and bottom, I can go ahead and make all those mortises loose. So the next thing I'm going to do is put the mortises in the end of the center divider to attach to the first panel. I'll do the mortises here, and then I'll start to do the mortises in the center. For attaching the center panel to the back divider, I'm just going to put 3 mortises in. 2 wood tenons and then 1 connector in the middle to lock it all together. So this is the center panel opposite of the panel that I just did on the other side of the divider. So I can complete the same exact process as I did on the other one, and then we can move on to the end panel. So now that we've got the backs of our center panels mortised, I need to do the bottoms so they will lock into the bottom panel as well. Now up to this point, the way I've been doing those is I'll line it up with the lines I've already drawn on my board, clamp them down, and then I can run my mortises in this direction and then reference the base of the domino off of this panel to mortise down that direction. But because since this panel is wider, I can clamp on the outside, but I can't clamp here in the middle, and it makes it a little wobbly for me. So what I can do is push those out of the way, get my Festool guide rail, line the back side up with that pencil line. Now I can reference my domino off of that. On this edge, I've got the edge to reference off of with my flap. That'll bring it in 37 millimeters. So on the other end, all I need to do is just hold my panel up here and just draw a pencil line on both pieces of material. Now I've got a reference mark here, and I've got a reference mark here. I'm gonna make my front mortise a loose mortise, and then this mortise on the back, the tight mortise. So I went ahead and flipped the center panels over. I'm gonna switch my plunge depth to 28. Now it's just a matter of referencing off this edge with my flaps, and then using those two lines I drew before to make the mortises. Then I can drill my two holes for my connectors. As I'm laying out these two panels for mortises, I keep running into clamping issues. So rather than struggle any further, I'm gonna get the STM 1800 out of here, and I'll bring in the MFT 3. That'll give me a lot more clamping possibilities. So with that all laid out, I can go ahead and put mortises in both of those panels and drill the holes for the connectors on the back side. You may choose not to use the domino connectors and just use clamps to assemble the entire project. That's totally fine. If you do use solid wood tenons, that's going to change whether your mortises are loose or tight depending on how you design your project. So now I can unclamp these two, set this one aside, and drill the holes for the connectors. While I'm set up for drilling holes, I'll go ahead and flip this around and drill the connector holes on this end as well. With those mortises done, I can remove these clamps. I'm gonna set this shelf aside for right now because I still have to finish some mortise on that. I can pick up this panel and repeat the process. So now with the shelf mortised out and this side panel mortised out, I can flip it around so I can get the mortises in the bottom panel. So now I can get set up to drill the holes for the connectors on this divider panel as well as the shelf. So all I have left to do is the mortises in this panel, and then all these mortises in the bottom are done. Then I can work on the top parts. Now I can finish up the mortises on this far left panel and continue working my way towards the right side. So now I can get this clamped down and do the mortises on the top of the center divider. Now I can work on the last two tall panels. And now I'll put the corresponding mortises into the Vaxis support. So now I can do the mortises in the bottom of the access panel to accept the end panel. Now I can do the corresponding mortises for this end panel in the top. With all the mortises cut and all the holes for the connectors drilled out, the next step is to sand everything down, get all my pencil marks off, so then I can do a dry fit. I'm not sure I'm going to finish mine yet. I may just put a clear poly coat on it. I may put an oil finish on there. In that case, I'm going to get all the pencil marks off. So when I'm sanding large surface areas, I like to jump up to a 6-inch sander like the Rotex. It may not seem like a lot, but just jumping from a 5-inch pad to a 6-inch pad gives me 30% more sanding surface area than with the 5-inch. So I've gone ahead and put 120 grit granite on here. That's typically what plywood's sanded to. So I'll go ahead and sand all the marks off. I'm going to be sanding in Rotex mode. So let's get to sanding. So with the joinery completed and the sanding completed, the next steps are going to be dry assembly, edge banding, and final assembly. Now the exciting part happens where we get to see things really start to take shape. But before we do that, we have to install the domino connectors, so then we can start doing a dry fit. So for this domino connector setup, we've got the expansion joint, which fits in the mortise like that. And then we've got the capture nut with the plastic capture ring that will fit inside the hole that we drilled prior to this. So what I like to do first is put the set screw in. Just get it started. You don't want it in too far. And then you'll install it in the hole you drilled previously and put the plastic capture ring in. Might have to give it a little tap. Biggest thing here is you want to make sure that it's completely flush. So now I can complete the same process for all the other holes that I drilled. So now I want to talk about the process of dry fit. We're going to have to create a sub-assembly of the internal dividers with the center divider, and then lower that onto the bottom panel, and then we can bring the top panel and attach it all together that way. For these two smaller panels that are going to connect to the center divider, I'm going to use a different type of connector. This is what I like to call a through connector. So when we did these mortises, I plunged all the way through because they're all in line with these two smaller panels. And these actually connect together. We'll go on either side of the panel and then connect to these connectors on the other side. So I'll assemble and install these, just one connector in the center, and then I'll put two solid wood tenons in the top and bottom. So at this point, I want to make sure that I adjust the dip that's in that shaft to line up with where my set screw is going to go. What I like to do is I usually hold the panel up, see where that set screw is, then just take the supplied screwdriver and point it in the same direction. So once I have one side installed, I can come to the back side, tighten this one up to do two things, to get the dish in the correct direction and also suck both those panels together. So now we can go ahead and put in the expansion connectors and the connecting rods to then attach this panel to the center divider. When you're installing the connecting rods and the expansion connectors, you want to make sure that you tighten them all the way down till you can't tighten them anymore. That expands those fingers and locks it into that piece of plywood. Then you can back them off to adjust them to line up with that screw. So now I can install the shelf so that I can put on the next panel. So with the sub-assembly dry fit, everything looks good. Now I can just slide it over a little bit, install my connectors and dominoes into the bottom panel. Then once that's done, I can dry fit the top. So I was able to get the sub-assembly lowered onto the bottom panel. It took a little bit of time, but I got it. Next step is to put the connectors into the top panel and dry fit that onto the top. So with the dry fit complete, everything went together nicely. The next step is going to be to start working on the face frame material. I need to do the vertical pieces before I do the horizontal pieces, because I'm going to have to trim these vertical pieces flush, because if you remember, we made them just a little bit wider than our 3/4 inch plywood. So first I'll break everything down for glue up, but that also gives me access to the individual pieces so I can get the edge banding put on them. So now that I've broken down the cabinet for glue up, gone ahead and wheeled in the Capex and got that all set up, I can pull some measurements off these center panels to cut down that maple that we ripped down earlier for the face frame material. So the pieces we're going to be cutting first are these vertical pieces. I've got 10 in total, 8 of them are going to be exactly the same length. Once I pull one measurement, I can go over the Capex, set my flag stops, and cut them all the exact same length. First thing I need to do is get a good clean cut on the end that'll reference off my flag stop, then I can cut the other 8 pieces. After verifying that my measurement was good, I can continue cutting. So with those all cut, I can now cut the short horizontal pieces and the shorter vertical pieces. So now I'll set the flag stop to just a hair over 19 1/4. Even though I'm only cutting 2 of these, I want to double check to make sure that this measurement's exactly right. So now I'll cut 2 at 17 1/2. So out of this stock, the last 4 pieces I need to cut are the 2 long pieces for the base and then 2 long pieces for the upper. So I'll cut these to 63 7/8. So I'll set this to 46 3/8. With all the narrow pieces cut, I can cut these 4 wider pieces, 4 in total, for the shelf and the storage area. The next 4 pieces I have to cut are shorter than what the Capex extensions can accommodate. So I already cleaned up one end of the piece of material and I measured my first piece. Then I've got a couple scrap blocks of wood. Once I've lined up my mark with the lasers on the Capex, I'll just put one block up against the bottom piece, and then I'll have another block on top of it. Now I've created a stop as well as a hold down to cut all 4 pieces the exact same length. And make sure the bottom piece of material is the same thickness as the material that you're cutting. I've gone ahead and I've attached about half the banding to the carcass material, but now I'm going to walk through the process of running the dominoes in and also trimming it flush top and bottom. So this end, I'm going to come off of this edge with the flaps, so this will be about 37 millimeters, and that'll be my alignment mortise. The rest, I'm just going to put a small pencil mark every 6 to 8 inches. So the first mortise will be tight, the rest are all going to be loose. Gone ahead and switched the domino machine over to a 5mm cutter because we're going to switch to 5 by 30mm tenons. I've adjusted my depth to 15 millimeters. I'm going to use the flap for the first one on the tight mortise, and the rest are all going to be loose. To put the mortises in the banding material, I'm just going to clamp it to the carcass itself. And because I know where I'm going to put each and every mortise, I know just to watch out for those marks. Clamp it down. This will be the same process I did on the carcass material. Start out with a tight mortise and the rest are all going to be loose. Next step in the process is to put the dominoes in the banding and then attach the banding to the carcass. I apply the glue to one side of the domino, put it in the mortise, do that to all of them, and then I'll apply glue to the face of the banding. With everything glued up, I can go ahead and put it on the carcass material, tack it on with my headless pinner, wipe all the excess glue off, and then we can trim everything flush. I've got the OF 1010 router with the edging plate set up on it. I've got a 2-flute straight cutting bit. I've adjusted the depth of the router and also the height of the edging plate so that I'm trimming perfectly flush with my carcass material. I always recommend doing a sample piece first so you don't damage your finished material. So with that piece trimmed flush, I can move on to the next couple pieces. I'll just mark it, mortise it, glue it, trim it, and then move on to the next piece. So this will be the last piece of banding for the main carcass pieces. Then the only thing we have left to do is domino the shelf fronts on the shelf itself. I also need to put a mortise here, 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 and here to attach these shelf fronts to these side banding pieces. I've gone ahead and laid out both of my pieces where my mortises are going to go. I'll be using the 5x30 tenon, so I'll keep my plunge depth at 15 and my fence height at that same 20 millimeter. Since I'll be doing a vertical mortise, I went ahead and put the support foot on. While I have this here, I'll go ahead and glue the dominoes up and attach the front. Now I'll do the same thing on the other end of the shelf. Now I want to add the bottom piece. This is just going to be a stop because this is going to be where I put some miscellaneous parts. I don't want it rolling out or falling out of the bottom. So I'll just dominoes together, glue them up, and we'll be ready to go. So this is the other side of this shelf. And I know what my measurement is from the bottom of this face frame material to the center of the mortise. I can just transfer that to these two pieces, make my mortises, and then assemble this as a sub-assembly. So the dry fit for the sub-assembly went great. Everything fits perfect. Now I can put some glue on it, set it aside. The last step before the final assembly is to put these mortises in that I have on the drawing. What these are for is material support. What I can do is cut these as 8mm tenons, and then I'll take a full-size 8mm tenon and I can put that in any one of those mortises. So if I'm supporting a piece of material vertically, it can rest on there and then I can clamp it to the MFT. On the drawing that I did originally, I laid out for 6 different mortises. I cut it down to 4 mortises, so all I did was take the measurement of my panel, divide it by 5 spaces, and that'll evenly space 4 mortises in this panel for me. So I put the 8mm cutter back in the domino. I'm going to set the plunge depth to 20 millimeters because I'm going to use an 8x50 tenon. So that'll leave 30 millimeters hanging out as my material support. Now I can begin the glue up of the entire full assembly. So now I've got everything glued up. Next couple steps are going to be do a little bit of light sanding, get rid of these pencil marks and some of that glue residue that might be left behind. Once those casters are on, then we can put the different drawer systems in for the sustainers. And to wrap everything up, we can put the MFT on top of the cart. Now I can move on to the sanding, where I'm going to get rid of some of these pencil marks and also some of the glue residue that was left behind. To do that, I'll be using the ETSC 125 as well as the edge guide, which will turn this into an edge sander to get some of this top edge banding. So with the majority of the large flat spots sanded, now I got to work on these narrow face frames. I could do it just with the ETS 125 by itself. It's a chance of it rocking. So I'm going to add the edge guide to it to keep it nice and flat and square. To change that out, I'll just be using a 5mm wrench, which is included with most of our saws, to take a couple screws out and attach it. I can just adjust it to whatever angle I want to sand at, which is 90 degrees for this, lock it down, then sand all my narrow face frames. If you have more questions about the sander or the edge guide, check out the link in the description. So with the sanding complete, we can move on to installing the casters. It's a fairly straightforward process, but I like to make it even simpler. Rather than measuring for where each caster goes, all 4 holes in each caster, I just made a jig. I'm doing an 1.5 inch offset from the front and the side. Drill my 4 holes, move to the next one, drill my 4 holes. That takes any chance of air out of the picture. I went ahead and tipped the whole cart on its side. This way I can reach all the different casters from one location. So now I can get them installed and secured. So I had some help with putting the cart on the ground after the casters were installed. Now with it down here, I can finish sanding this top, and then I can put the MFT up there. So now I've got the MFT on top of the cart. I want to make sure that it doesn't move while it's on top of the cart. So I've cut some little blocks that I'll put where each foot is at, and that'll lock it into place. And I'll put it right where it's going to touch the foot of the MFT. Draw a couple lines, I'll take the table off, glue and nail it into place. So as far as the storage goes on my rolling workstation, I'm going to be utilizing our sustainer system. And in that, we have both the L-size T-lock sustainers as well as the standard T-lock sustainers. For the standard T-lock sustainers, I can use the SysAZ drawers. And that comes with the drawer slides already installed, comes with instructions on how to install it, as well as the screws. For the L size, we're going to be using the sustainer guide rails, and those just go on like that. You have to provide your own screws, but it also comes with a set of instructions on the dimensions you need to build your storage case for. These will work with any of the Sys Gen 3 sustainers. So I'm going to start over here because this is one of the areas I designed for the SysAZ drawers. And then I'll go around the entire cart and install the lowest drawer first, and then I can design it however I want depending on the size sustainer that I'm going to be using. For the Sys 3 rails, I'm just using posi drive 5mm Euro screws to install. For now, I'm just going to store my TSC in there. I'm not going to put any drawers in there. Down the road, I may have some ideas of what I can build to fit in there. If I do end up putting rails, I've got the holes pre-drilled. So with this complete, I now have a central location for tool storage, assembly, cutting. That's all mobile. And as I build out my shop, I'll be able to maneuver this where I need it the most. I built it the same height as my Capex UG stand. It'll also be the same height as my cabinets and countertops that I'm putting in. That way it helps with efficiency throughout the shop. Now you can see what I had in mind when I was cutting these mortises for these material supports early on in the project. In a small shop like this little additional design will really add to the versatility of this cart. Now I can see what this little drop down was for, the Vaxis. I can store it here, I can use it here, and it stays out of the way of the MFT and any material that might be on top of it. I'll also be storing the vacuum pump back here on a Sys AZ drawer so I can access that whenever I need to. Thanks for watching this build series. I hope you enjoyed it and you learned a couple things along the way. Now I've got a lot of projects planned, so if you'll excuse me, I've got a shop to build.